For years, the cloud was just marketing spin, a way for Amazon, Google, and Microsoft to make data centers sound magical. The reality? Massive concrete warehouses consuming more electricity than small countries. Millions of gallons of water evaporated daily just to stop the chips from melting. But on November 2nd, 2025, something changed that should make you uncomfortable. StarCloud-1, backed by NVIDIA, became the first satellite to operate a production-grade H100 GPU in low Earth orbit, delivering 100 times more compute power than any previous space-based system. The mission validated that 4-nanometer silicon designed for liquid cooling on Earth could survive the thermal extremes and radiation environment while executing real AI workloads. Google's response came within 48 hours. Project Suncatcher, an architectural proposal for 81 satellite clusters carrying custom Trillium TPUs, interconnected via free space optical links, designed to scale from prototype to terawatt-class orbital compute by the 2030s. It's a fundamental restructuring of AI infrastructure. The constraints that limit terrestrial data centers don't apply in dawn-dusk sun-synchronous orbit. And the companies racing to prove orbital viability are betting that whoever controls space-based compute will control the future of artificial intelligence. Let's get something straight. AI is not running out of data. It's not running out of ideas. It's running out of electricity. Right now, data centers consume roughly 415 terawatt-hours annually. That is about 1.5% of all electricity on Earth. By 2030, that number is projected to hit 945 terawatt-hours. We're talking about doubling energy consumption in 5 years. Half of America's new power generation will go directly into feeding these machines. But electricity is only half the nightmare. The real crisis is water. To keep H100 GPUs from thermally throttling themselves into paperweights, data centers evaporate millions of gallons of fresh water daily. Google's data centers alone consumed 5.6 billion gallons in 2022. That's enough to supply 50,000 homes for a year. We've hit a wall. A hard, physical, thermodynamic wall. Google, NVIDIA, Microsoft, Amazon, they all see the same ceiling. If they stay exclusively on Earth, their AI roadmaps flatline by 2028. The exponential growth curve that Wall Street demands? It dies in the desert heat of Arizona, starved of power and water. So, they've made a decision that sounds insane but is brutally logical. If Earth can't feed the machine, we leave Earth. So, why space? It isn't for the view, it's for the energy density. On Earth, solar power is fundamentally flawed because of a little problem called night. The sun goes down, clouds roll in, seasons change. To run a data center on solar power down here, you need massive battery farms to store energy for the dark hours. That doubles your cost and your complexity. In space, there's a sun-synchronous orbit where the sun never sets. You get hit with raw, unfiltered solar energy 24 hours a day. We're talking about 8 times the power generation potential compared to a panel on your roof in California. It is a river of free energy that never stops flowing. It sounds perfect on paper. You have unlimited energy in a vacuum that is technically freezing cold. But here's the catch that the shiny press releases and the concept art always gloss over. Space is a vacuum. On Earth, you use air or water to carry heat away from your computer. You blow air over a heatsink, the air gets hot, and it moves away. In space, there is no air. There is no water. Convection does not exist. The only way to get rid of heat is to radiate it out as infrared light. It is incredibly slow and inefficient compared to a simple fan. So, while these companies have all this free energy coming in, getting the waste heat out becomes an engineering nightmare. They aren't just building computers, they are building massive radiators with thrusters attached. This brings us to NVIDIA. They moved first and they moved loud. In October 2025, they announced the StarCloud partnership, and by November 2nd, StarCloud-1 was in orbit. It's carrying an H100 GPU, the same chip powering the early versions of ChatGPT, just sitting in a chassis, moving at 17,000 miles per hour. NVIDIA's play here is aggressive, but if you follow their history, it's exactly what you'd expect. They are trying to copy-paste their Earth dominance into orbit. They want the standard. They want you using CUDA in space just like you use it in your basement, your university lab, or your massive server farm. They're partnering with StarCloud to build these massive 4-kilometer arrays. Stop and think about that scale for a second. 4 kilometers. That isn't a satellite, that is a megastructure. It dwarfs the International Space Station. NVIDIA is selling the dream of a data center in the sky that looks exactly like the one on the ground, just without the electric bill. But by pushing these high-wattage, power-hungry GPUs into a delicate orbital environment, they are taking a massive gamble on thermal management. Blackwell chips are designed to draw huge amounts of power to get that inference speed. To cool that in a vacuum, StarCloud is going to need radiators the size of football fields. Then you have Google. Their response, Project Suncatcher, announced just 2 days after the StarCloud launch, feels entirely different. It's colder, more calculated. It feels less like a stunt and more like an infrastructure project. Google isn't trying to put a generic server in space. They are launching their own custom silicon, the TPUs. These chips are designed for one thing and one thing only: training AI models. They strip out all the graphical baggage that comes with a GPU. Google isn't interested in selling you a general-purpose computer. They are building a walled garden in low Earth orbit. Their plan involves swarms of smaller satellites talking to each other via free-space optical lasers. It's a distributed brain. If one node dies, the others route around it immediately. This is smart because it mitigates the risk of a single catastrophic failure. If a piece of space debris takes out one of NVIDIA's massive StarCloud arrays, the whole system might go dark. If Google loses 5 satellites, the mesh network just reroutes the traffic. But it's also a trap. If you use Suncatcher, you are likely using Google's chips, Google's software stack, and Google's proprietary laser communication protocols. You aren't just renting a server, you are buying into a proprietary physics architecture. NVIDIA wants to be the hardware supplier for the orbital gold rush, selling shovels to everyone. Google wants to be the mine, the pickaxe, and the bank. But there is a bigger enemy up there than each other: physics. Space is hostile in ways that a climate-controlled server room in Oregon is not. First, you have radiation. We aren't protected by the atmosphere up there. High-energy protons and cosmic rays are constantly bombarding these electronics. This causes bit flips, where a 0 turns into a 1 in the memory. Google tested their Trillium chips against simulated proton beams and found uncorrectable errors. They say it's manageable, that the AI inference is robust enough to handle a little noise, but the reality is that radiation degrades silicon over time. These data centers have an expiration date. They will literally rot from the inside out. And then there's latency. Light is fast, but it's not instant. A signal has to go up 500 kilometers, get processed, and come back down. That adds milliseconds. It doesn't sound like much to a human, but for high-frequency trading, autonomous driving, or real-time gaming, it's a lifetime. This means these orbital clouds are useless for anything that needs instant reaction. They are strictly for batch work, training a massive model overnight, processing terabytes of climate data, or running molecular simulations for drug discovery. It splits the market in two. The fast, hot, expensive stuff stays on Earth because we need the speed. The slow, massive, cold thinking happens in space. It's a new kind of digital divide defined by altitude. Google and NVIDIA aren't just selling compute, they are selling a specific kind of compute that forces developers to change how they build software. You can't just upload your app to space and expect it to work the same way. You have to architect around the speed of light. This is where the fear comes in. We are talking about launching 4-kilometer-long structures into a zone already filled with 30,000 pieces of tracked junk. One marble-sized piece of debris hitting an NVIDIA array at 10 times the speed of a bullet doesn't just break the server. It turns that server into a cloud of shrapnel. This is the Kessler Syndrome, a chain reaction that turns our orbit into a swirling cage of debris. If we mess this up, we don't just lose our data centers. We lose the ability to leave Earth. We lose the stars. And from a security standpoint, these are the most valuable machines in history, floating in a place where no one can protect them. No guards, no walls, just a signal that can be jammed or a satellite that can be physically sabotaged. We are putting the keys to our civilization in a glass house. But let's talk about the money, because right now the math simply does not add up. Google's own internal analysis, which was discussed in their white paper, suggests that for orbital data centers to actually compete with Earth prices, launch costs need to drop to around $200 per kilogram. That is the magic number. Where are we today? Even with SpaceX reusing Falcon 9 boosters, we are hovering around $2,500 per kilogram. We are an order of magnitude off. We are 10 times more expensive than we need to be to break even. The proponents argue that solar power in space is free. It's not free. You paid a rocket company millions of dollars to put the solar panel there. That is your energy cost. It's just front-loaded. Instead of paying a monthly electric bill, you pay a massive launch fee up front. The cloud is no longer a metaphor. It is becoming a physical shell of silicon and glass surrounding our planet. Google and NVIDIA aren't just tech companies anymore. They are becoming orbital superpowers. They are solving their Earth-bound problems by exporting them to a place where we can't see the damage. But we will see the streaks in our telescopes. We will see the debris in our atmosphere, and we will feel the lag in our connections. The race for the high ground has begun, and while they look at the sun and see unlimited power, we should be looking at the sky and wondering what happens when it starts falling. The first NVIDIA H100 is already up there, circling the Earth every 90 minutes. Project Suncatcher launches in 2027. If you want to know what happens when the first orbital cluster fails, or when the first laser link is hijacked, you need to be here. Hit the subscribe button and stay tuned. The future of AI isn't on your desk anymore. It's in the stars, and it's more dangerous than you think. Thanks for watching. See you in the next one.